Alright, 11.4, a new section, but related section. Let's recall what we did in the first three sections. We learned about quadratic equations. We solved quadratic equations. We also solved quadratic looking equations, not exactly quadratic, but looking equations yesterday, such as this one. It's not quadratic, but we can make it quadratic with substitution. Today we are going to graph them. We'll learn how to graph certain format of quadratic functions, not in general. We will learn how to do it in the next section for any general quadratic functions, but special formatted ones are gonna be done today. Okay, so graphs of quadratic functions is our subject. You all know what a quadratic function is, right? Basically a square function. This is what necessary in the equation. Ax squared, a number times x squared, or sometimes just x squared, 1x squared. As long as you have this, we call it quadratic. What are the other two then? They are just additional items, not optional items. Sometimes they drop out, sometimes both appear, sometimes one of them appear. But if all three are together, this is called a trinomial as well. This is the standard. Most often you see all three together, but quadratic functions are basically square functions and also some numbers and x variables as well. But no higher than square, and you don't expect to get other powers, just x squared and first power. Alright, when you graph them, their graphs are, or their pictures are very basic. You either get regular U letter shape. Look, this looks like the letter U, right? U-shaped object, regular orientation, both branches are going up, or sometimes you get upside down U letter. Okay? So it looks like either a mountain, this is like a mountain top, right? And this is like a valley or cavity, hole, okay? So it's either U-shaped or upside down U-shaped. But when does it become U-shaped? If the number, very first number in the equation, this number I'm talking about, is positive, then we have a shape like this. Look at the example. It's 1x squared plus 4x. We don't care about this. Look at here, 1x squared, positive 1. So we have a U-shaped object here. But if it is negative 1, do you see this negative sign here? It's negative 1 times x squared. I don't care about the rest. And it's upside down. It has a maximum and two branches are growing down, opening downward. Here you have a minimum value, like deep down value in the valley, and then two branches are opening up, opens upward. It's like a seed you drop into the earth, and then there are two branches are sprouting. Again, this is like a seed, but two branches are going down, like a root. Okay? Very basic shapes, right? All you need to do is make these shapes and you're done. Question is, where is that seed located? Sometimes it happens here, sometimes it happens down there. You need to find the location of the seed, and you need to, sometimes those branches are skinny, like very sharp going up. Sometimes they are wide like that. How wide are those things, and whether they are upside down or not? So this is our topic, describing how much it's shifted up, down, left, right, how much it's wider or narrower, and whether it's upside down or not. It's our topic today. Alright, we are sketching with very basic, starting with basic ones. This is our base function. This is the base function. Please take a look at this one. What is that? It's x squared. Everybody must recall its graph. So this is our base function or reference function. Do you know the graph of x squared? It's this black curve right in the middle. Put it down somewhere. It's crossing x-axis and y-axis at 0. So it's starting, the seed is on the center. Seed is at 0, 0. And everything else just evolved from it. All other quadratic functions can be graphed from this base function. Look, they added 1 to the base function. Add 1. What happened to graph? It's the red graph right now. What just happened to the graph? Look. Can someone describe what happened to it? It moved, right? Moved which direction? The seed moved how much? And where? 1 up. So adding 1 means move 1 up. That's it. All you gotta do is move the curve, the seed actually, where it starts, 1 up, and branches will sprout. What if you subtract? Somebody subtracted 2 from your base function. Look, all your values used to be 9, 7, 4, 2, 1, minus 1. All the values dropped 2 units. And you got this blue picture. Look at the blue picture. Do you see that? Blue one? What happened to your seed and other values? It dropped, moved 2 down. There you go. You just discovered the rule. When somebody adds a number to the end of x squared, your base function moves up as much as that number if that number is positive. If you see a positive number, it moves up as much as that. If you see, what does this mean? K less than 0. Negative, then the function graph will move down, go down as much as that k unit. If it is minus 5, it's 5. You take its absolute value, move it 5 down. Okay? Is it clear? Alright, here is our first question. Can you graph this picture? Without any table, don't make any table. You don't have to. This is time consuming. I mean, don't redo all this. It's time consuming. This is 3-second question if you know what you're doing. Let me give you the starting thing. This is x squared. This is your base function. It's in dashed because that's not the actual graph you're supposed to make. This is your play material. Change this material into the main graph. So what is the real graph then? What do I do with this? We move up how much? Up how much? 3. So all you need to do is take this and that, move 3 up. 1, 2, 3. 1, 2, 3, and make the new graph. It used to be at 0, now it's at 3. Okay? There you go. You're done. Very simple, huh? Yeah, we start with very simple questions, but it's gonna get serious later, okay? So which one is the right fit? A, B, C, D. Which one? Looks like C. 3. Between 2 and 4, 3. Going left and right. Yep. So please don't do trial and error. Choose every option and retry. No. You need to first answer this on pen and paper without seeing the options, draw it, and then pick the right option later. Otherwise you will not learn it and you will mess up, okay? because I won't ask multiple questions in the test. So none of these will happen on the test. I will maybe ask something different, okay? So you need to learn how to do this on paper. So, can you describe what's going to happen to our main graph? This is again our original function. This is x squared. How do you make x squared minus 5? Describe it. Goes down. So here we go. Just mark those special points, such as you know the location of this one, right? This is at 0, -5. Or simply it's -5 on y-axis, right? Okay, let's pick the right choice. What option? D. Not this, not that, not that, D. Alright, moving on. Let me know if you have any questions, but it should be pretty simple so far. What is different in the equation? Look, we start with the base function. This time, yeah, I see numbers added and subtracted, but what is the difference? Main difference there. Where are those numbers? 1 and -2. Compare 1 and -2. Here 1 and -2 in old stuff. If 1 and -2 is on the end like this, it moves up and down. Where is 1 and -2 now? Look here and there. It's under the square together with x. Do you see the difference? These two things are not the same. X squared minus 1 versus x minus 1 squared. Do you see the difference? If you don't see a difference, then you're in trouble. If the number is added or subtracted inside under the square, it's going to make what kind of shift? So the black one is your base function. It shifted here and there. If you add and subtract, what kind of shift is this called?
Horizontal shift.
Yeah, that's what it says here, but in our own words, which side? Left and right. Yeah. I don't use this technical word. I call it left-right shift. Right? Who cares, right? It's either gonna left shift right or left, but which way? This is kind of opposite. This is tricky because most people fail at this point. If they see +1, they shift it to the right because positive values on the right, correct? X values are positive on the right, and you kind of tend to shift right. It's opposite. This is left shift. And I see negative numbers on the left. I feel like this is left shift. No, our feeling is wrong. This is right shift. So when I have a minus, I'm shifting right. Where? From 0 to 2 units right. 2 units. 0 to 2. When I have +1, I'm shifting left. Look, +1. I'm shifting left to -1 when I shift left. Okay? And this is the whole story explained here. It's really confusing, right, what it says here, but it's basically what I explained. Right and left, that's it. Alright. Who wants to make picture of this? I mean, describe the picture. It's a parabola. Our base parabola, this parabola, shifted where? To right, left. So move 1, 2, 3, 4, 5 left and mark that value and possibly write it down. -5, 0, the coordinates, right? And we will just make 2 branches sprouting. Alright, let's pick the right option. Which option is that? A. Okay? Alright, 4. Guess what's gonna happen? Alright, you do this. And you tell me which option. A, B, C, D. This is A, this is B, this is C, this is D, okay? A, B, C, D. And cover with your hand so nobody can see it, okay? So, which one is right? Oh, you don't see that? X minus 5 squared. Let me see hands. Don't cheat. Come on, back row. They may be wrong. They don't know nothing. I'm just kidding. Alright, that's true. It's C, number 3, C. Because minus 5 is gonna shift it 5 right. I just wanna make sure, is this 5 though? Between 4 and 6, yep, it's 5. Alright. So I'm not sketching this, it's here. Alright, things are getting different. This time you don't have a number added or subtracted inside or out. What is this operation? What operation do you have here? A number coming in front and multiplying it. If the number if the term x squared is multiplied, there are two scenarios here. Multiplied by 2, multiplied by 1 over 2. What's the difference? 2 is a big number, 1 over 2 is a small number, because 1 over 2 is 0.5, right? So the criteria here is, listen up, 1. If the number is more than 1 or less than 1. This is less than 1. Less than 1. This is more than 1. More 1. If it's more than 1, look, all the numbers are doubled. Quite bigger. If it is less than 1, 9 becomes 4.5. 4 becomes 2. Get halved. So things are shrinking. Things are stretching. Getting bigger. If the number is more than 1, look, black one is our base one. Base is black. 2 comes in front and everything moved up. Look, this point used to be here and it doubled. This point used to be here and it doubled. And this point used to be here and it doubled. Everything stretched twice up. The technical term for this is, we don't call it move up. Move up is used for the addition. It's stretched. Somebody, like a rubber band, pulled this and moved, stretched up twice. Okay? But if it is 1 over 2, 0.5, 1 over 2 half, everything is now shrunk, shrinking. Look, this point used to be here, it shrank down to here. Now this point shrinks here. Every point goes half the distance back. So 1 over 2 shrinks twice, stretch. Okay? Shrink and stretch moves happening here. Well, there is a different scenario here. What is different now? What are these numbers? Negative numbers. What if you multiply? Because all the numbers here were positive. Positive, big, small. Negative, big, negative, small number. First off, because of the negative sign, your base function flipped upside down. Okay? So negative sign reflects the graph along x-axis. Look, it used to be like this, your base function, black one, turned upside down, reflected along x-axis, made upside down. So negative brings upside down, but 3 still stretches it. Look, this is the 3. It made it skinnier. Stretching means making kind of skinny or getting close to y-axis. It's a lot steeper. The angle is, or the dive is really high slope, diving really fast. This is diving slowly and even slower. Okay? And, oh, by the way, I'm sorry. The base one is blue one, not black. Black one is minus 1 over 3x squared. The base function is x squared turned into minus x squared, the middle one. Again, small negative means down, upside down, flip. 1 over 3 means shrink. It really shrunk. It widened or get fat, right? It's not narrow anymore. Make sense? Alright, let's practice. Oh, this explains what I just said in technical terms. Again, if you have a small number, look, a less than 1, positive small number, it shrinks. A more than 1 is big positive big number, it stretches. Well, if it's negative though, look, a is negative, this is negative small, negative small, negative small, makes this shrink again. Negative big number, a is negative and this time big, negative big number, it stretches, but it's upside down. Alright, here is our first question about multiplication. Just tell me the effect. What kind of change is going to happen on the picture? Let me put down the original. This is original x squared. Is it gonna, what? It's gonna be thinner or it's gonna be stretched, right? It's gonna be like this. Yeah. I stretched it, but I also moved the seed location. Seed used to be 0, 0. I moved it up some units. This is wrong. The seed still nailed down the same position. The seed doesn't move. So in stretching, any point on x-axis stays on x-axis. You're not shifting it. Don't shift. Only like if this is nailed here, you're extending this rubber by pulling from these arms, okay? So number 5, which one seems the right option? Look, this is shifted. The seat location changed. No. No. This looks wider than original. This is the real stretching one. How can I really test this? Just take a value if you wish, like 2. This is twice 2 squared is 8, so that's 4. When you have 2, you got 8. And you enter 2, you got 8. 2, 8 must be on the picture. This should be, for example, 2, 8. And check if 2, 8 is on this picture of your choice. This is 2, 8. Is it on the picture? Yeah. None of them, nobody else has that. So this one has 4, 8 on the picture, not 2, 8. So option is part B. But again, don't go with, this is for checking purposes, making sure. You need to first do it on scratch paper, get the right answer done. If you want to check back, make sure that's for insurance, okay? Alright, tell me the results. Shrink or stretch? This is original again. It's going to be underneath or above? Underneath. Shrink. It relaxes. These points are going down. Okay? So which one is on the list? A. The wide one. Narrow, narrow. This is even shifted. Shifted, wrong, wrong, don't shift. Narrow, wide, wide open, and at 0, 0. So multiplying by a number doesn't change the seed location, so it's A. Can't choose A. Where is it? Alright, this goes really fast and smooth because these are warm-up exercises, okay? So tell me, describe me the picture again. Here.
The same one we did earlier, but upside down.
Yep. This exact picture here, you turn it upside down, like that. Same width, same size, but upside down because of what? Negative. Negative is upside down. 2 means stretch. So I first flip original upside down, then I stretch it. That's it. So all upside down, shifted, neither B or C can be right. Is it A or D though? A? D. Because it's the one, skinny one. Alright. Is it similar to 6? No, this is 1 over 4. This is 1 over 2. And don't miss this, minus sign. So this is upside down. What does this do? What does it do? Yeah, it's going to make it shrink or wider. Just do a wide picture, but let's put down the original so we can refer to this. Size refers to this. This is original x squared. Just put a wider upside down picture like that so I can compare them. So option which one? A? Why not D? These looks like wide as well. Because the center or the seed is not origin anymore. That one is wrong. Okay. Now it's getting serious. Why? Look at the title, please. How many operations do you see? How many transformations do you see on the formula? Look, I see a subtraction or addition. I see a subtraction or addition. Although this is plus, I'm saying subtraction or addition because how do you know k is positive? What if this is minus 3? Adding a minus 3 turns this into a subtraction. That's why I'm considering both options. So just because this is minus, this is plus, doesn't mean they are guaranteed to be that way. This can be plus, this can be minus as well. Two operations so far, and there is a third one. Multiplication too. There is a multiplication, the third operation. So the following questions will involve three transformation. Shifts up, right, left, down, left, right, up, down. Multiplication, stretch or shrink can be all together. Okay? So we are gonna do that, but this is called, actually there is a special name for this version. It's called vertex form of quadratic functions. Any quadratic function can be flipped into this form. Look, very first picture here. I said this is a quadratic function, right? This is the equation of the quadratic function. Quadratic functions look like this, but this is really useless. Standard form of quadratic function is useless because you cannot read any information from here. It's just ax squared bx plus c. So what we are going to do in the next section is actually we will turn this into x minus h squared plus k. This is called vertex form. I call this the useful form. We will change flip to here, because with this form you can read a lot of information, harvest a lot of information about the graph and its properties, as you see in this list here. You can find out the seed location. I call this seed. You can find it out. All you need to do is look at these two numbers. These two numbers will tell you where the seed is. You can read the axis of symmetry. It's only x equals this number. Look, I'm reading all this information from this equation. You take h and set it into x, that's axis of symmetry. By the way, what's the axis of symmetry? It's the line crosses perpendicular to the parabola or quadratic function right between the branches. Left and right branch is split into two equal halves through it. So this is called axis of symmetry. This is. Again, how do I find it? It's always x equals something. X equal a location here. And you to find that location, all you gotta do is check the x coordinate of the vertex or this number. Okay? Depending on the shape, your parabola can have either minimum or maximum, not both. If it's a regular U-shaped, it has a minimum, and the minimum value is actually the second coordinate. Always k, the second coordinate, or this number is the minimum value. If it's upside down, it can have a maximum only, and the maximum value is k, which is the y coordinate of the vertex, or again the number on the very end of the expression. Is everything clear? Alright, let's show this, apply this in a problem. You will understand better. Alright, it says graph parabola and the axis of symmetry first. Let's do the graphing first. But you haven't done any graphing like this before. Because how many numbers do you see around x? This is not just x squared. How many numbers somebody added or subtracted? How many? 3? 3? What are they? Yep, this is the first one. What is the next one? First. Okay, this is second. What's the third one?
Plus 3 again.
Hmm?
Is it plus 3 again? Squared?
No, that's the first one. This is second operation done. What's the third one? You said 3. Do we have a third? No. Don't count square. If you're thinking square is an operation, no. It was already in the base function. X and square was already in the base one, so they are staple values. There are only 2 operations or transformation done to this main graph. So this is your x squared. You are going to transform it twice according to these numbers. But how? What does adding 3 to x does? No, it doesn't raise. Yes, this is a left shift. Left by 3. Right? You guys started to confuse already? Look, if you have a number inside, it's either left or right. If you have a number outside, it's up or down. Got it? Yeah, it takes some time to get used to. But this is left by 3. What is this one? What kind of shift is it gonna make? -5. This is down. Down by 5. So do what it says here. Left 3. 1, 2, 3. Move it here. And then down 5. So your seed first moves here and then goes down 5. 1, 2, 3, 4, 5. Left 3. And then down 5. Look, this is your new seed. There are 2 sprout. Oh, is this going to flip upside down or something? No, there is no negative sign in front. So there are 2 branches popping up from here. And make them. Okay? So this is a rough estimate. Roughly. So this, I'm not sure where this exactly crosses it. It could have been later or sooner or later, but this is roughly my estimate. So clean the rest. You don't need to show the rest of the work. This is my final picture. Alright, here is my question. Do you guys remember the coordinates of this point? Can you write it? What is this called again? Seed or vertex is the technical name for it. I'm wondering its coordinates. Anyone?
-3, -5.
We moved 3 left, 5 down. So it is -3, 5. -5. But what if you weren't tracking my moves and you didn't have this picture? Could you write vertex directly from this equation? Could you? How?
You did it, but you have to take into account that it would be that you're going opposite of, you're moving left for the function.
So we are taking opposite of this variable, which is take opposite of this number. It's +3, right? What is opposite of +3? -3. And you're taking this as it is, because -5 is down 5 directly. It's not opposite. And -5. Look, you don't need the picture to find location of the vertex, seed. All you need is these 2 numbers. +3, you flip it to -3, and -5, take it as -5. You found vertex. We need the axis of symmetry. So they are asking me the line that goes right through the vertex up and down, splitting this parabola in 2 pictures, 2 equal halves. Can you tell me the equation of this line? It's looking at you actually. This location is negative 3, so it is x equals negative 3. But could you write this directly from the equation without seeing the picture? Yes, it's always opposite of this number or first coordinate of the vertex. What I'm telling you is you don't need the picture to harvest this information. You can get all this information from the equation too, not picture necessarily. Okay? We graphed these found vertex, write the equation of axis of symmetry. Alright, what we need to finish off this question with is domain and range. Do you guys remember how we used to find domain and range? Back in, I don't know, all chapters. Domain is the set of all x values this function takes in to make this graph. Range is all the set values, so set of y values those x values are assigned to, turn into. So range is found on y-axis, domain is found on x-axis. How? Anyone recalls? Yep, exactly. To find domain, you're gonna press this up and down to x-axis. Smash this to x-axis. What do you observe? And imagine these arms, branches are going indefinitely to the right and left. What is it? Yep. It's these points are gonna fall down, these points are gonna fall up, and it's gonna fill up all this space here. All this space is gonna fill up with points, smashed points, right? So domain is everything from left end to right end, no gaps, no holes. So it's one entire line minus infinity to infinity. Alright, be careful with range. Range is the same, right? We smash it from sideways now. Smash this thing from sides. From this side and that side. This is going all the way up, so it's infinity. Am I right?
Infinity, parentheses, positive infinity, comma, negative 5, right?
Look, this is a cereal bowl. It has an end on the bottom. It doesn't go indefinitely all the way down. So it starts here, and it never ends up, because this is going up moon. Unlimited size cereal bowl, but it has a bottom. Since it has a bottom, you need to start with that bottom, which is -5, and it's included because you really can obtain that value. It's filled in, but it never stops going up, so the other end is infinity when you smash it to y-axis. Alright, we need to carry all this information to here, to our question. First, pick the right question we pictured, right option we pictured. Which one? It's moved left of x and down 5. Is this the one? This is moved right and down. No, not up. Should be A. So we pick first the right picture. That's A. What is next? Vertex. Where is the seed? Seed location. Vertex is seed. It is -3 and -5. We actually found it here. -3, -5. Axis of symmetry was x equals the first coordinate of the vertex. Domain is the entire real line, entire x-axis technically. but the range was limited. Half line starting at -5, but it never ends. It goes up, up, up. Okay? Any questions?
Read bottom from top when you're doing range.
Right, that's good point. When you're reading range, you always read from bottom to top. So that's why we start with -5 and infinity. Alright, here's a new one. But this time, how many operations do you see? In the previous one you said 2. This time, 3. So this is even more challenging. 1, 2, 3 shift, shrink or stretch happened here. Technically it's 4. 4 transformation happened. 3 numbers but 4 transformation. Why? What's the 4th one? Negative was gonna make it upside down, so somebody flipped it upside down, so that's counts like a separate one, 4th one. But you can handle it. Alright, describe me where this our main base function moves. How does it transform, change? Describe me. Let's start with the end. What does this do? No, down, right? Down 3. What is this? Left 4. What's this? Upside down. What else? And shrink or stretch? No, stretch. It will get skinny. It will get skinny. Because twicing it, you're twicing, it's gonna be steeper, steep angle, okay? Sharp. Alright, let's do what I said to this graph. So first down 3, down 3, I'm at -3, and then left 4, left 4, upside down, turn it upside down, and stretch. 4 moves, look, down, left, upside down, and stretch. And I'm going to put my final picture here. Is it clear? Down, left, upside down, stretch. Okay?
When we do it in the problem, it won't have the right side up on there, will it?
It
You
won't.
don't have to put that in.
No, it's you're just gonna pick a choice, A, B, C, D, okay? But again, down for shrink and stretch, skinny picture coming in. Or I need to know what this point is, and I lost count. I forgot tracking it. Can you tell me by just looking at this numbers? From here you can tell the coordinates of this thing. Where is it? I lost count. What is it? Yeah, opposite of this number, -4, and the actual number on the end. That's it. You're done. You found vertex. That's it. How about axis of symmetry? We need to show that. Here is axis of symmetry. Can somebody help me write it? X equals, what is it? -4. This number here. Okay? We pictured this, wrote this, and domain and range. Let me tell you, domain of a parabola or quadratic function never changes. It's always negative infinity to infinity. It's gonna always open left and right and cover entire x-axis. Okay? It's always that. But the range, help me find range. Now smash this. from the sides to y-axis, what's the picture? Is this so? Correct? So how do you write this? Minus 4 is this value, right? So it is minus 4 and minus infinity going down. Minus 4 minus infinity, right? Oh, minus 4 should be included, correct? So that's it. That's it? Mistake. There's a mistake. Yeah, this is wrong order. I told you. Read from bottom to top. It's negative infinity, negative 4. Alright, let's move all this to the question. Which one is the right option? This one sitting right on the center, wrong. This one is also, no, this is minus 4. Sorry, this is 4. So just find the vertex you're done. It's what's the vertex location? Minus 4, minus 3. This is minus 4, minus 3. So this is one candidate. This is also minus 4, minus 3. This is also one candidate, but it should be upside down. So B is right now the right choice. Minus 4, minus 2, wrong. This is not the right vertex. Minus 4, minus 3. So it can be B or D. Which one? B or D? D. We need to go with the skinny one, right? It's stretched, so it's D, option D. Vertex was minus 4, minus 3. Axis of symmetry was x equal minus 4. Domain is, this is always the same, minus infinity to infinity. Quadratic functions let everybody in. I mean, they allow all x values, so no exceptions. But the range is limited. Negative infinity to y coordinate, negative 3. I think I typed it wrong here. Why did I say negative 4 and nobody fixed me? This is wrong. Should be y coordinate minus 3. This is minus 3. Wait, I'm wrong. Oh, I forgot the bracket. Thanks. Well, we have a couple more questions left, and then we'll continue our final section afterwards.